Hello po, good morning everyone. Yan po, magandang umaga po sa ating lahat. And the National Mapping and Resource Information Authority is pleased to welcome all of you to today's webinar on Environment and Natural Resources, or ENR Mapping Initiatives, in support to climate change adaptation. So the conduct of this webinar po is in line with our celebration of the 2023 National Climate Change Consciousness Week with the theme Bayanihan para sa Klima, Bagong Bansang Matatag. So before we proceed with the webinar proper, let us start our program with a prayer.
Dear God, thank you for the opportunity to meet together. Please help us to come together to make this institution reflect your kingdom. Breathe life into our ideas and decisions. Help us build a team that has love and respect at its heart. Give us the strength to continue working for your kingdom in this time of pandemic. Lord, come give us the inspiration to be the best we can be. May we be a shining example of your goodness and truth within, wherever we are. Inspire our thoughts, discussions, and ideas, and continue to remind us that all that we do here today, all that we accomplish, is for the pursuit of truth for the greater glory of you. We ask these things in your name. Amen.
Ayan. Again, a pleasant morning to each and everyone here in our Google Meet, and of course, to those who are currently streaming in our YouTube Live. So I can see that we have colleagues from NAMRIA, and we also have participants from other agencies. I think they are from other national government agencies, and we also have registrants from the local government units, private sector, from the academe, and who else? Ayan po. Eh, medyo marami silang mga nag-good morning dito. Hello po sa inyong lahat. Good morning everyone po. So again, welcome to our webinar on ENR Mapping Initiatives in support to climate change adaptation. So I am Joyce Ferrer, your host and facilitator for today. So as I have mentioned earlier, this activity is in line po with the celebration of the 2023 National Climate Change Consciousness Week, or the 2023 NCCC Week. Tatlong C yun. Ayan. The National Climate Change Consciousness Week was declared as a celebration by the Presidential Proclamation number 1667. So for this year's theme, we have Bayanihan para sa Klima, Bagong Bansang Matatag. So we are conducting this activity in order to, one, share information on the ENR initiatives of NAMRIA in relation to climate change. Number two, we want to create awareness on the mandates and roles of NAMRIA and its contribution to the national development. And of course, three, we would like you to still have fun while learning about topics related to climate change and the environment. So to formally open our webinar, let us hear a message from the Officer in Charge Director of the NAMRIA Resource Data Analysis Branch, OIC Director Sylvia L. Esperanza. Ma'am Sylvia.
Good morning, Joyce. Thank you.
Morning po.
Pleasant good morning to all our online participants from the NAMRIA, DNR, other national government agencies, local government units, academe, and the private sectors. I am delighted to welcome you all to this learning event in line with the celebration of the National Climate Change Consciousness Week with the theme Bayanihan para sa Klima, Bagong Bansang Matatag. The National Change Consciousness Week is being celebrated to create awareness on global warming and climate change through the conduct of intensive public information and education campaigns to secure the collective and cooperation of the public and private sectors. As a central mapping agency, NAMRIA produces various geospatial data that play crucial role in understanding, monitoring, and assessing the impacts of climate change. In this webinar, resource speakers from the Resource Data Analysis branch of NAMRIA will present two of the ENR mapping projects that provide the necessary geospatial information that are crucial for informed decision-making towards the sustainable management of our environment and natural resources. These are the land cover and the coastal resource mapping projects of NAMRIA. This webinar will explore how the national land cover and the coastal resource maps are being produced with the application of remote sensing and GIS technologies and their relevance to climate change. May this webinar serve as a platform not only for awareness and knowledge sharing, but also for collaboration. I hope this will ignite new ideas and inspire us to do sustainable practices in our own way for our Mother Earth. Thank you once again for joining us. But before I end, I would like to express my gratitude to our organizers from the Geospatial Information System Management Branch, our resource speakers from the Resource Data Analysis Branch, and the NAMRIA Management for supporting this activity. Again, good morning everyone, and mabuhay po tayong lahat. Back to you, Joyce.
Yes po. Thank you po, Ma'am Sylvia, for your opening message. So like Ma'am Sylvia, we all hope that everyone streaming in the YouTube live now will learn from our activity. So before we proceed with the lectures po, let us watch the NAMRIA audio-visual presentation.
Do you know that 80% of the information needed in everyday life deals with the location or geography of people, places, things, and events? And one of the essential tools to help people locate objects, features, and events and navigate their way on the surface of the Earth is maps. Maps provide information for planning, decision-making, operations, and governance. The National Mapping and Resource Information Authority, or NAMRIA, plays an important role in generating and managing maps and geospatial information. It is a government agency attached to the Department of Environment and Natural Resources, or DENR. As the country's central mapping and geospatial information management agency, NAMRIA serves the needs of the government, the private sector, research institutions, and the general public. NAMRIA's mission is to provide quality topographic maps, nautical charts, and other geospatial information and services in a timely and coordinated manner. NAMRIA envisions itself to be a center of excellence, building a geospatially empowered Philippines where geospatial information is fully used in making important decisions and conducting daily activities. NAMRIA has 4 core functions: topographic mapping and geodetic reference frame development and management. NAMRIA produces topographic and derivative maps at various scales, in paper or digital forms. These are used as basic tools and references for infrastructure and development planning, disaster risk reduction and management, environmental protection, research and development, investment planning, and resource exploration. Pursuant to Executive Order Number 192, NAMRIA is mandated to establish and maintain the primary geodetic control network for all surveying and mapping activities in the country. hydrography, oceanography, charting, and maritime boundaries mapping. NAMRIA conducts hydrographic and physical oceanographic surveys and produces nautical charts such as berthing, harbor, approach, coastal, general sailing, and overview charts covering the country's maritime territories and jurisdictions. The agency also publishes predicted tide and current tables, coast pilot books, list of lights, notices to mariners, and other nautical publications. Nautical charts and publications ensure safety in maritime navigation and provide basic information for the management of the maritime space and resources, as well as base data for climate change studies. Charts and hydrographic data are important in complying with the provisions of the United Nations Convention on the Law of the Sea relative to the delineation of the country's maritime zones and the safety of navigation requirements of the International Maritime Organization. NAMRIA spearheaded the preparation and successful validation in 2012 of the country's submission to the Commission on the Limits of the Continental Shelf for an extended continental shelf in the Benham Rise region, now called the Philippine Rise. It also provides technical support to the national government in establishing and delimiting national boundaries and addressing maritime territorial and jurisdictional issues, and the local government units in delineating municipal water boundaries. Resource assessment and mapping.
NAMRIA produces maps that provide data on land classification, forest and land cover, coastal resources, low-lying areas vulnerable to sea level rise, boundaries of protected areas, and other environment and natural resources. These fundamental data sets serve as vital inputs to policy formulation, physical and development planning, provision of social services, disaster risk reduction and management, and climate change mitigation and adaptation studies.
Geospatial information management.
NAMRIA's functions and services include geospatial databasing, application development, GIS trainings, and packaging of geospatial knowledge products and services. NAMRIA also plays active roles and acts as lead in local and international programs in the area of geospatial information management and services relevant to disaster risk reduction and management and climate change adaptation. NAMRIA spearheads the implementation of the National Spatial Data Infrastructure, or NSDI. A major output of the NSDI is GeoPortal Philippines, which serves as a platform for online and open sharing of geospatial information produced by NAMRIA and other government agencies. NAMRIA also assists Congress in the crafting of priority bills on maritime zones, archipelagic sea lanes, land classification, comprehensive land use, and protected areas, among others. NAMRIA is certified to ISO 9001:2015 standards for mapping and geospatial information management, and is accredited by the Investors in People for international standards on good people management practices. It is staffed by around 800 people, 70% of whom are holding technical positions like oceanographers, hydrographers, geodesists, cartographers, photogrammetrists, foresters, remote sensing technologists, and geographic information system or GIS and information technology specialists. NAMRIA maintains the following facilities: active geodetic stations, multidisciplinary survey vessels, a magnetic observatory, a network of 60 primary tide stations, the NAMRIA Geomatics Training Center, the NAMRIA Data Center, which houses GeoPortal Philippines, the National Oceanographic Data Center, map sales offices, client service units, the NAMRIA Museum of Surveying and Mapping,
and a special library holding a comprehensive collection of maps and other related materials. From its humble beginnings in 1987, NAMRIA has come a long way and stands firm in accomplishing its mandated tasks and responsibilities to its clients and stakeholders and to the goals of DENR. This is the National Mapping and Resource Information Authority, an agency helping to build a geospatially empowered Philippines. Welcome to NAMRIA.
The land cover mapping and the coastal resource mapping. So without further ado, let us call on our first resource person to discuss the land cover mapping, senior remote sensing technologist from the NAMRIA Land Resource Data Analysis Division.
Let me just share my screen. Joyce, just checking. Okay ba yung screen ko? Can you see my presentation?
Yes po, ma'am.
Okay. So again, thank you, Joyce. Good morning, everyone. And thank you for joining us in today's webinar in celebration of this year's National Climate Change Consciousness Week. I am Bonifacia B, a senior remote sensing technologist at the Land Resource Data Analysis Division, Resource Data Analysis Branch of the National Mapping and Resource Information Authority. So this morning, I will talk on NAMRIA's land cover mapping project and the significance of the land cover map in the context of climate change adaptation initiatives. So this presentation will cover the following topics. First, I'll give a brief introduction to NAMRIA and the land cover mapping project, followed by the history of the land cover mapping initiatives in the Philippines, and then the detailed process and methodology in generating the land cover maps. And then the presentation will also explore the significance of the land cover map in climate change adaptation efforts. And finally, we'll close by discussing the challenges encountered in the implementation of the project and our priorities moving forward. Okay, so you've heard and seen this in the audiovisual presentation a while ago, but let me just again give you a brief introduction to our agency. So the National Mapping and Resource Information Authority, or NAMRIA, is a central mapping agency of the country. NAMRIA was created by virtue of Executive Order 192, Series of 1987, and is mandated to provide the public with map-making services and act as the government's central mapping agency, depository, and distribution facility for natural resources data in the form of maps, charts, texts, and statistics. Now, the agency performs the following core functions. So first we have hydrography, oceanography, charting, and maritime boundaries mapping. So this involves the measurement, description, and mapping of features of the country's waters for the safety of navigation and in support to all maritime activities. Another core function is topographic mapping and geodetic reference frame development and management. So NAMRIA produces topographic maps at various scales for use of stakeholders for development planning and disaster risk reduction and management, among others. So next core function is Geospatial Information Management, or GIM. And the GIM services include information strategic planning, geospatial databasing, information and web system development, and GIS trainings and technical assistance, among others. And lastly, we have resource assessment and mapping. Okay, so as mentioned in the previous slide, resource assessment and mapping is one of the agency's core functions. And this involves mapping and assessment of various environment and natural resources geospatial information to generate new or updated data and statistics. So the Resource Data Analysis Branch, or RDAP, is a branch that implements this core function. And in RDAP, we have the following projects. So first we have land cover mapping. We also have coastal resource mapping, and then forest land evaluation and mapping, and of course, participatory mapping of existing land uses. So these are the four main projects in our branch, the Resource Data Analysis Branch. And of course, our primary focus is on the land cover mapping project. So I keep on mentioning land cover and land cover map, but what do these terms mean exactly? So land cover pertains to the observed physical and biological cover of the Earth's land as vegetation and man-made features. And a land cover map shows the spatial extent and distribution of various land cover types such as trees, shrubs, grass, water bodies, crop areas, and barren land, including artificial surfaces. Okay, so let us now talk about the land cover mapping project. So one of the mandates of NAMRIA is to generate the land cover map using the latest satellite imageries. This project specifically aims to produce updated land cover maps and statistics through the application of remote sensing and GIS technologies, complemented by a ground validation survey. Now, the maps and statistics will be generated by province, and this will serve as vital input in physical and development planning for various stakeholders. Now, the land cover mapping project is a nationwide assessment. So this covers the 82 provinces of the Philippines, and the land cover map is updated every 5 years. So these are the previous land cover mapping initiatives undertaken by NAMRIA. Okay, so first we have the 2003 Land Cover Mapping Project, which is a joint undertaking of NAMRIA and the Forest Management Bureau, and this was implemented in 2000. Now, this project intended to generate a nationwide land cover map at the shortest possible time. Now, that is based on a classification scheme that is consistent with international standards. Now, with a short project duration, a nationwide land cover map with 21 categories based on FAO was produced through visual interpretation. But since it has a short duration, this had no field validation. Then, in 2006, the 2003 land cover map was updated using various satellite imagery. So as you can see here, we used ALOS Apnir 2, Spot 5, and Landsat 7 ETM. And the methodology employed was visual interpretation, but this time this had ground validation. Now, to facilitate mapping and interpretation, the 21 land cover categories from the previous cycle was aggregated into 14 aggregated land cover categories. Okay, so let us now go to the 2015 land cover map. So this land cover data series used Landsat 8 imageries with 30 meters resolution. Now, the satellite imageries were digitally interpreted through object-based image analysis, or OBIA, combined with visual interpretation. And of course, this was complemented by ground validation. And again, to facilitate mapping and interpretation, the 14 land cover categories from the previous cycle were further aggregated into 12 land cover classes. Excuse me. Okay, so let us now discuss our latest release, which is a 2020 land cover map. So NAMRIA started updating in 2017 for the 2020 land cover map. Now, the primary data source that was used for this project was Sentinel-2 satellite images acquired between 2017 to 2020, and a total of 105 Sentinel scenes were used for the whole country. As in the previous cycle, the data were interpreted using digital image classification, utilizing object-based image analysis, and then combined again with on-screen visual interpretation. Now, this also had 12 land cover classes, consistent with the classification scheme of the previous cycle. Now, in terms of validation, the preliminary land cover maps for the first 60 provinces were validated on the ground, and that was before the outbreak of the COVID-19 pandemic. However, for the remaining 21 provinces, image validation was employed, wherein sampling points were validated through visual inspection of satellite images with higher spatial resolution, such as Google Earth or PlanetScope. Okay, so here now are the land cover map series from 2003 until 2020, and a comparison of the land cover classes and satellite imageries used for each cycle. Okay, again, so as I've mentioned from the previous slide, the 2003 land cover map was generated using Landsat 7 with 30 meters resolution, taken in 2000 to 2003 with 21 land cover classes. Whereas the 2010 land cover map used a seven ETM taken in 2006 to 2011, and this had 14 land cover classes. Now, for the 2015 land cover map, Landsat 8 image taken in 2017 to 2020. Okay, so this slide shows a comparison of the classes of the land cover series. Now, for the 2003 data, the 21 categories used in mapping were based on the Philippine Forest Inventory Field Manual compiled and edited by the FAO Forestry Department. Now, for the 2010 cycle, in order to facilitate mapping and interpretation, the 21 land cover categories were aggregated into 14 classes based on DNR Memorandum Circular 2005-05. Now, as you can see here, the three types of closed forest, we have the broadleaf, mixed, and coniferous, were aggregated into one class, which is closed forest. And this is similar to the three types of open forest, which were aggregated into one class, which is open forest. However, for the forest plantation, either broadleaf or coniferous, these were classified either as closed or open forest or other categories based on their current condition. Now, for the 2015 cycle up to the present cycle, the 14 land cover classes were further aggregated into 12 classes. But as you can see here, this time it's the fallow and wooded grassland that were aggregated into one class, either brush shrubs or grassland, depending on their condition, while the rest of the classes remain. Okay, so as I will be discussing a lot of terms involving remote sensing and satellites, I will first give a quick review on remote sensing. So what is remote sensing? This refers to the activities of recording or observing objects at far away or remote places. The output of a remote sensing system is usually an image representing the scene being observed. So as shown here in this GIF image, satellites hovering around the Earth capture and record information about objects or phenomenon on the Earth's surface. Now, the information gathered by a remote sensing system is useful for a variety of applications, such as we have here for coastal applications to monitor shoreline changes, track sediment transport, then also for ocean applications like to measure ocean temperature and wave height, and of course for hazard assessment to track hurricanes, earthquakes, erosion, and for flooding, and of course for natural resource management, such as in monitoring land cover and land use, in mapping wetlands, and charting wildlife habitats, among others. So how does this information captured by the remote sensing device turn into data? Now, this next slide will show you the flows of energy and information in a remote sensing system. So these are the components of a remote sensing system. Now, the first requirement is to have an energy source which provides electromagnetic energy to the target of interest. So in this example, the sun is our primary source of electromagnetic energy, or EMR. Now, once this uh, electromagnetic energy, or EMR, travels from the sun, it will come in contact with the atmosphere, thus the atmospheric interaction. Now, the energy from this interaction will be recorded by the sensor or remote sensing device. Now, those EMR that successfully pass through the atmosphere will come in contact with the target. And depending on the property of both the target and the EMR, the electromagnetic radiation could either be reflected, scattered, absorbed, and later on emitted. Now, the energy that was reflected, scattered, or emitted from the Earth's surface will be collected and recorded by the sensor. Okay, so the energy recorded by the sensor has to be transmitted, of course, often in electronic form to a receiving and processing station where the data are processed into an image. Now, the processed image is interpreted visually or digitally to extract information about the target which was illuminated. And the final element of the remote sensing process is achieved when the data is transformed into valuable information, such as what we have here, maps, charts, and of course, statistics. So this is an example of a satellite image, which is Sentinel-2. Now, this is the data source that was used for the 2020 land cover map as well as for the present cycle. So note that the satellite image has 13 spectral bands with spatial resolutions of 10, 20, and 60 meters. Now, this has a revisit period of 5 days from the two satellite constellations, and its radiometric resolution is 12-bit. Okay, so I described the sentinel image a while ago, and these are the four types of sensor resolution mentioned in the previous slide. Okay, so first off is the spatial resolution, which refers to the level of detail in satellite imagery. So this is determined by pixel size on the ground. So higher spatial resolution enables more precise identification and analysis of features on Earth. So for Sentinel-2, bands come in variable resolutions from 10, 20 to 60 meters. Next, we have temporal resolution, which is the frequency at which satellite captures images of the same location. Now, higher temporal resolution allows monitoring of dynamic processes such as vegetation growth, weather patterns, and ocean tides. Now, for Sentinel-2, the 2 constellation has a revisit time of 5 days. Another resolution is spectral resolution, which refers to the number and width of wavelengths captured by a satellite sensor. Now, greater spectral resolution allows precise identification and analysis of materials and phenomena based on their unique spectral signatures. Now, in our example, Sentinel-2 has 13 spectral bands, ranging from the visible range up to the shortwave infrared. And lastly, we have radiometric resolution, which measures the sensitivity of a satellite sensor to detect and distinguish different levels of brightness or color. Now, higher radiometric resolution enables the detection of subtle variations in surface properties like vegetation health or water quality. Now, for Sentinel-2, the radiometric resolution is 12-bit, which gives a potential range of brightness levels from 0 up to 4095. Okay, so those are the 4 types of sensor resolution. So remote sensing has numerous applications really across many fields. So for coastal studies, it allows researchers to track sediment movement and model shoreline changes over time. In agriculture, remote sensing data enables the monitoring of crop health and yields over large areas. It also facilitates forest mapping and the tracking of drought conditions. So overall, remote sensing provides spatial information that supports research and analysis in coastal dynamics, agriculture, forestry, and environmental hazards, among others. Okay, so let us now discuss the methodology employed in generating the land cover map through the land cover mapping process. So the land cover mapping process consists of 3 major phases. We have the input, the process, and then the output. And let us begin, of course, with input. So the primary data source that was used for the 2020 land cover map, as well as for our present cycle, is Sentinel-2. And this is a multispectral satellite data consisting of 13 bands. However, for our purpose, we used only 7 of these bands, which we found were most useful for land cover mapping. So as you can see here, we used the bands 2, 3, and 4, and then bands 8 and 8A, and bands 11 and 12. Now, so we chose Sentinel-2 as our primary data. Why? First, because it is free and downloadable. And again, it has higher spatial resolution, spatial and temporal resolution compared to our previous source, which is Landsat. Okay, so for free satellite imagery, you can download from the Copernicus Data Space ecosystem or the EOS the Land Viewer. So shown here in this slide is, so since Sentinel level 2A is already atmospherically and geometrically corrected, we only had to do resampling to match the resolution of the bands and then layer stack them to come up with a single multispectral image. Now, if a province covers more than one image, we mosaic them or subset them as needed. So we also do image enhancement to aid in the interpretation. And then after that, we can then proceed to image classification. So after pre-processing, our next step is to create a normalized difference vegetation index or NDVI, which serves as input in the object-based image analysis. And likewise, to assess the changes in land cover, we generate an NDVI difference image, and this will be shown in the next slides. So NDVI, this stands for Normalized Difference Vegetation Index, and this measures the greenness and the density of the vegetation captured in a satellite image. So the NDVI values are calculated as the normalized difference between the red and near-infrared bands of the satellite imagery. And the normal range of NDVI is from -1 to 1, where higher values indicate healthy and dense vegetation, while the lower values signify sparse or no vegetation. Okay, so this image shows an NDVI map derived from Sentinel-2 for the province of Cavite. So as you can see here, the high NDVI values, which indicate dense vegetation, are located in the western and lower portion of the image. And in contrast, the northern portions of the province, which are highly urbanized, have low NDVI values. This is now the difference image of Cavite province, which identify areas of vegetation change. So the difference image is derived by subtracting the NDVI of the new cycle with the old cycle. So positive values indicate an increase in vegetation, while negative values suggest a decrease. Areas with minimal change will have values that is close to 0. Now, from the NDVI difference image, we can identify areas in the land cover map with major changes, and this will be shown in the next slides. So for the first slide on change detection using NDVI, this area shows positive vegetation growth with the land cover transitioning from brush shrubs to open forest. This one is similar to the previous slide. This transition signifies an increase in vegetation from grassland to brush shrubs. So this area exhibits a transition from fish pond to mangrove, which signifies an increase in vegetation. So this transformation could be indicative of the restoration of mangrove ecosystems. And then for this next slide, the construction of the new road resulted in a decrease in vegetation as brush shrubs and grassland were cleared from the area. So this removal of natural plant cover will reflect as low or negative values in the NDVI difference image along the route where the road was built. This area depicts a decrease in vegetation resulting from the conversion of grassland to built-up areas. Now for this slide, this area has undergone expansion or reclamation, as some portions were previously unclassified and has now become built up. Okay, so after those slides, okay, so now that we have done the NDVI difference image, the next step in the process phase is image classification and sampling points generation. The next step is utilizing object-based image analysis, or OBIA, to create a classified image. We chose OBIA over the traditional pixel-based image classification since OBIA segments the image and groups small pixels into objects, taking into account not only the spatial but also the spectral properties of each pixel as they relate to each other. So with OBIA, the steps involved are performing image segmentation and then collection of training samples to be used as input for the image classification. And of course, classification is never perfect, so we do editing as needed. Now, our next step is to use this preliminary land cover map to generate sampling points through stratified random sampling that we will use for field and image validation. So in this example, as you can see, there are a total of 521 sampling points, 104 of which were validated on the ground. And the last steps in the process phase are the verification activities, which include field validation, accuracy assessment, and presentation of the land cover map to the stakeholders. Okay, so shown here are the activities we undertake in verifying the accuracy of the preliminary land cover map. So prior to the actual field validation, first we coordinate. So following the coordination activities, field teams conduct on-site surveys to validate land cover classifications. This involves the identification of sampling points on satellite imagery, followed by ground-level verification of the actual land cover. And for our fieldwork, a key improvement in the latest land cover mapping cycle is using ArcGIS field maps on mobile devices. So ArcGIS Field Maps is a mobile app that lets field teams collect data on their phones and tablets. It has easy forms and maps to record locations, photos, land cover types, and other information. Now, with this application, teams can gather high quality and accurate data in the field, which can be used to update and maintain land cover maps. So once field validation activities are completed, the survey results and preliminary land cover map are presented to the stakeholders through an exit conference. Excuse me, to solicit their feedbacks and additional inputs. Now, stakeholders are engaged to review the draft map products, provide comments, and offer supplemental data to improve the accuracy of the land cover map. So let us now go to the accuracy assessment. So for the accuracy assessment, we present this in a confusion matrix table, which shows the accuracy between the classified map and the reference data. So overall, the accuracy should be equal or greater than 85%. Of course, if there are errors that have to be updated, we do another set of editing to come up with a validated land cover map. So shown here is the classification accuracy for the 2020 land cover map. And note that the overall accuracy for the 20 LCM is over 90%. And then during the output presentation, the validated land cover map is what we present to our stakeholders, and this include the DNR offices, specifically DNR regions, PENROS, and CENROS. And we also invite participants from the local government units, academies, NGOs, and other offices identified with using the land cover map. Now, if there are any comments during the presentation, we validate these corrections and incorporate them to produce the final land cover map. And for the new cycle, NAMRIA introduced the ArcGIS sitemap, which is an online platform that allows stakeholders to provide comments and feedback on the preliminary land cover map. The platform's innovation enables participants, regardless of their geographical location, to contribute to map enhancement as long as they have an internet connection available. So going back to the land cover mapping process, the last phase of the land cover mapping process is the output, and the final output is the land cover map by province in shapefile and geodatabase format. And of course, we also deliver analog format with corresponding statistics. So this is the 2020 land cover map and statistics, and this data provides helpful insights into the current distribution of various land cover types. Note that the forested areas account for more than 24% of the total land covered area of the country. So in terms of the Philippine forest cover trend, so our forest cover in 1934 was more than half of the total land area of the Philippines, or equivalent to 16.9 million hectares. However, in 2010, it was drastically reduced to 6.84 million hectares. But as you will see in the next slide, there is also an increasing trend in forest cover. So as you can see here, forest cover had also increased from 7.01 million hectares in 2015 to 7.22 million hectares in 2020, corresponding to an increase of more than 200,000 hectares. The forest cover statistics in the Philippines is increasing since 2010 due to the implementation of various projects and programs, in particular, the reforestation and protection efforts of the government and other stakeholders. Now, what is the importance of land cover map for climate change effort? So a land cover map can help us understand the current state of the environment, its potential vulnerabilities, and how it changes over time. This map shows the different types of land cover and how they change over time. And by understanding these changes, decision makers can develop policies that help mitigate the effects of climate change, such as reducing greenhouse gas emissions and protecting vulnerable ecosystems. Now, what is the role of land cover map in understanding climate change efforts? So first we have for vulnerability assessment. Land cover mapping enables the identification of regions vulnerable to climate change impacts such as floods, landslides, and other climate change related hazards. Now, this information is important for creating specific plans to adapt to these changes. And by understanding the different types of land cover and how they change over time, we can better prepare for and respond to the impacts of climate change. With at-risk areas delineated, government and organizations can strategically implement adaptive measures to mitigate hazards and strengthen community preparedness. Now, mapping vulnerable zones facilitates focused resilience planning and intervention by public and private sector stakeholders, building climate preparedness at the community scale. And of course, engaging communities in mapping vulnerable areas facilitates public education on climate risks, drives participation in resilience initiatives, and leverages local knowledge to enact solutions tailored to community needs. Now, this inclusion and empowerment of residents is key for developing effective, equitable adaptation policies with grassroots supports. So here are just a few applications of land cover data in climate change adaptation measures. So land cover data enables the monitoring of deforestation rates, helping to address critical issues such as illegal logging and habitat loss. Another application is mapping land cover facilitates tracking urban expansion, enabling sustainable urban planning and reducing the environmental impact of urban growth. And of course, for marine ecosystems, so land cover mapping extends to coastal and marine areas, assisting with the conservation and restoration of vital ecosystems like the coral reefs and mangroves. And of course, we also encountered some challenges and limitations in the implementation of the land cover mapping project. So first, we have remote sensing limitations. So one of our biggest challenge lies in the prevalence of cloud cover, which significantly affects the quality of captured images. So given the tropical nature of the Philippines, a considerable portion of the acquired images exhibits high cloud cover percentage. Second, we have the frequency of update of the land cover. So NAMRIA currently follows a 5-year cycle for updating the national land cover map. However, some of the stakeholders have expressed interest in transitioning to a more frequent update given the need for a timely data in policymaking and global reporting. And another challenge encountered is the dynamism of land cover changes poses challenges in continuously updating the NAMRIA land map, especially in regions experiencing rapid land use transformations due to urbanization or large-scale development. Okay, so for this project, here are our ways forward. So to fast track the nationwide updating of land cover data, we are doing in-house research and proposing a research collaboration with other agencies on the application of artificial intelligence on land cover mapping. Another way forward is the continuous collaboration with the Philippine Statistics Authority and the United Nations Statistics Division for the SIA ecosystem accounting. So the UNSD and the Philippine Statistical Authority, or PSA, are currently making use of the ARIES for SIA application in the 3-year project Environmental Economic Accounting for Evidence-Based Policy in Africa and Asia. Now, in the Philippines, this project will focus on land cover and ecosystem extent accounts. Though the PSA and NAMRIA are currently working together to integrate national land cover data into ARIES to derive ecosystem condition accounts. And lastly, to engage stakeholders to provide comments and feedback on the preliminary land cover map via the land cover mapping project site. And of course, the land cover map and other environment and natural resources data can be accessed through the Philippine Geoportal online platform. So maintained by NAMRIA in collaboration with partner agencies, the Philippine Geoportal serves as a central public repository providing open access to key national geospatial datasets. And that's about it. Thank you very much po. Maraming salamat sa inyong pakikinig. Mabuhay tayong lahat. Back to you, Joyce.
Thank you po, Ms. Steph. Thank you very much po for that informative and very comprehensive discussion about the land cover mapping and its relation to the pressing issue of climate change. So, naintindihan niyo po ba at nakuha niyo po ba lahat ng diniscuss ni Ms. Steph? Ayan. We know that the discussion may be a little bit technical for all of you. So, as much as possible po, we try to laymanize yung mga terms and yung discussion para mas maintindihan po ng lahat. So, if you have questions po pala regarding our presentation, ay, yung presentation ni Ms. Steph and of course yung next nating presentation, you may send or type in your queries po sa ating YouTube, how do you call this, live chat. And we will try to answer po all of that later on sa question and answer portion. But for now po, let us have a 3-minute water or restroom break. And we will resume at, sabihin na nating 10. Okay lang ba, Sir Jeff? 3 minute pero 10. Sige po. Ayun po. Thank you.
Nakamute ka, Christian.
Ah, ah. 30 seconds.
Hello po, good morning po ulit sa lahat. Nakabalik na po ba from our break? Ayan. So hindi ko na po patatagalin pa. Moving on to our second lecture. So our second lecture is about the coastal resource mapping, which will be discussed by our remote sensing technologist from the Physiography and Coastal Resources Division of the Resource Data Analysis Branch. Remote sensing technologist, Mr. Christian J. Soliven. Sir CJ, good morning po.
Good morning, Joyce. Good morning, everyone. Let me just fix my slides. Okay. So can I get an confirmation if the slides are clear? And
Yes, sir. Kita naman po.
again, good morning, everyone. In observance of the 2023 National Climate Change Consciousness Week, this webinar on ENR Mapping Initiatives in Support to Climate Change Adaptation. I am Christian Joe Sullivan, a remote sensing technologist too, from the Physiography and Coastal Resource Division. And it is my privilege to present to you the second lecture for this morning on the coastal resource mapping and assessment implemented by NAMRIA and some impacts of climate change. So to start, let me show you the outline of this presentation. We'll start with the definition of climate change. We'll continue to discuss the climate change impacts and the coastal resource mapping and assessment project being implemented by NAMRIA, its objectives, methodology, the Sentinel-2 image, the object-based image analysis or OBIA, and the coastal resource map, and the ways forward. A short definition from UN of climate change. Climate change is the long-term shifts in temperature and weather patterns. Of course, in millions of years, our world has been warmer and colder than it is now. But since the 1800s, human activities have been the main driver of climate change.
CJ? Oh, excuse me. Hindi gumagalaw yung PowerPoint mo.
Okay, sorry. Sir? Okay po. Sorry. Okay. Ay, okay na po. Nag-move na po ba?
Yes.
Okay,
Thank
okay.
you.
Sorry for that. Okay, so in millions of years, our world has been warmer and colder than it is now. But since the 1800s, human activities have been the main driver of climate change, primarily due to the burning of fossil fuels like coal, oil, and gas. Burning fossil fuels generate greenhouse gas emissions that act like a blanket wrapped around the earth, trapping the sun's heat and raising the temperatures. Rising temperature is a key indicator of climate change. The line plot shows yearly temperature averages from the 1880 to 2020 as recorded by NASA, NOAA, and other research centers. Though there are minor variations from year to year, it shows rapid warming in the past few decades. And all show that last decade as the warmest. Some effects of rising temperatures are the melting of ice caps and glaciers, extreme weather events, there are threats to ecosystems and it poses health risks to humans. Sea level rise is a result of rising temperature that rapidly melts polar ice caps and glaciers worldwide. The melted ice adds water to oceans, causing sea levels to rise. On this graph, the data show that the recorded global sea level rise at 3.3 millimeter per year, according to NASA. But the local sea level rise recorded in Metro Manila for the period of 1965 to 2022 is at 14.4 millimeters per year, 4 times faster than the global average. This will lead to coastal erosion, inundation of low-lying areas that will result to displacement of coastal communities, saltwater intrusion to freshwater sources, and loss of coastal ecosystems. Another impact are the extreme weather events. More tropical cyclones are entering the Philippine area of responsibility than anywhere else in the world, as also shown in the map. With an average of 20 tropical cyclones in this region per year, with about 8 or 9 of them crossing the Philippines. This map shows the tropical cyclone paths in the Western Pacific from 1966 to 2017, with the most frequency in the Philippines. And one of these extreme weather events occurred 10 years ago on November 8, 2013, when Typhoon Haiyan, known in the Philippines as the Super Typhoon Yolanda, made its first landfall in Diwan, Eastern Samar, was one of the most violent tropical cyclones ever recorded. It caused destruction in the Visayas, particularly Samar and Leyte Islands, and NDRRMC confirmed a total of 6,300 recorded casualties and 95.48 billion pesos of estimated damages. Now, climate change also has impacts on coastal ecosystems. On coral reefs, rising temperatures stress corals, leading to coral bleaching, where corals expel the symbiotic algae living in their tissues that causes corals to turn to white. Extreme weather events can also physically damage corals through strong waves. Sea level rise is also a threat to shallow water corals. Increased submersion reduces the amount of sunlight reaching the corals, which is vital for their photosynthesis. So in this slide, is shown the effects of coral bleaching and extreme typhoon events. In addition, World Research Institute, based on its study, has projected that by 2030, up to 90% of coral reefs will be exposed to degradation, like coral bleaching and other destructive forms caused by human activities. Rising ocean temperature can lead to stress and mortality, and rising ocean temperature can lead to stress and mortality, and sea level rise can also lead to excessive submersion, affecting their growth and survival. And according to Fortes, mangrove forests, likewise, are constantly being threatened by natural and human factors, with the extensive conversion of these coastal resources to aquaculture and fish ponds during the 1960s to 1980s, purposely for food security and other coastal development activities like refilling and reclamation, which contributed to about 50 to 70% loss of mangroves during those periods. Okay. The immense economic and ecosystem value of these coastal and marine resources plays an important role in socio-economic development and climate change mitigation and adaptation plans and programs of the government. Increased migration to coastal areas, unregulated human activities, and other destructive processes, including changing climate patterns, have brought enormous pressure on these ecosystem-based resources. As part of the commitment of NAMRIA to the DNR, national government agencies, the civil society groups, the academe, public and private companies, international bodies, and other stakeholders in the production and provision of maps and statistics for environment and natural resource datasets. The Coastal Resource Mapping and Assessment Project aims to map the spatial locations of the country's coastal and marine ecosystems, particularly coral, seagrass, and mangroves. This will serve as baseline data or information for our policy and decision makers for the management, protection, and development of these vital natural resources. It also provides updated information and maps on coastal resources through the application of remote sensing and GIS technology complemented by ground validation. It also encourages the active participation of the role of women in nation building as part of the gender and development mainstreaming that will reduce gender gaps in the workplace. Okay. So what are the coastal resources that we are mapping? First, the corals. These are the hard calcareous substance made up of the skeleton of marine ecolenterate polyps, which include reefs, shells, and atolls, or any of the marine coelenterate animals living in the colonies where their skeletons form a stony mass. So did you know that the world's richest center of marine life and coral diversity, which has 76% of world's coral species, is called the Coral Triangle, located in the West Pacific, which includes the waters of Indonesia, Malaysia, Papua New Guinea, Timor-Leste, Solomon Islands, and of course the Philippines. Another coastal resource that we are mapping are the seagrasses. These are the marine flowering plants or angiosperms that grow in sediments on the floor with erect, elongated leaves and buried root-like structures or rhizomes. Benthic marine algae that live either in marine or brackish water environments. They are found in the coastal region between high tide to low tide and in the subtidal region. Okay. So, did you know that the largest single organism in the world based on area is a specimen of Posidonia australis seagrass, also known as the Poseidon ribbonweed, located in Shark Bay, West Australia. It covers 200 square kilometers or 450 times bigger than the Vatican City. Okay? And of course, we are also mapping the mangroves. These are plants which predominantly grow in the intertidal area of tropical and subtropical shorelines. The widest mangrove area and most species are found in Southeast Asia. They can tolerate salt water and oxygen-poor soil. They have propagules able to survive in and dispersed by salt water. So did you know that mangroves are remarkably tough? Most thrive in muddy soil, sand, and coral rocks, and they can live in water up to 100 times saltier than most plants can tolerate. Okay? So what are the importance of these coastal ecosystems? First, these coastal ecosystems are home to diverse habitats that provide shelter and breeding grounds to many aquatic species. They also provide food security. These ecosystems play a critical role in ensuring global food security through fisheries and aquaculture, providing a significant portion of world's protein intake. And it also acts as natural barriers for coastal protection from erosion and storm surges. They are also very effective in carbon sequestration and storage. They capture and store huge amounts of carbon, helping mitigate the impacts of greenhouse gases on climate change. So in this slide shows the previously released coastal resource map over the years by NAMRIA. These are the 2015 and 2020 coastal resource map. The 2015 coastal resource map was generated using Landsat images from 2012 to 2016, while the 2020 coastal resource map was generated from 2016 to 2021. Also included on the 2020 coastal resource map is the Kalayaan Island Group. So for the statistics, this is derived from the 2020 coastal resource map. The Philippines has corals of 1,257,684 hectares. For seagrasses or seaweeds, we have 498,341 hectares. And for mangroves, we have 311,400 hectares. So what is the methodology that we follow in the production of the coastal resource map? First, we have the preliminary data preparation. This is where we gather the latest Sentinel-2 image available and generation of the preliminary coastal resource map. The preliminary coastal resource map is then carried to field survey for conduct of validation of the preliminary maps using generated sampling points. Corals and seagrass assessment are also done in the field. Inaccuracy assessment, data editing and analysis, image validation are also done using visual interpretation of available reference data, such as satellite images with higher spatial resolution. The results are calculated by comparing the ground data and classified data to come up with the confusion matrix. And the corals and seagrass percent cover are also analyzed from the assessment data gathered from the field. Misclassified polygons are also edited based on the validation results. These results are presented to stakeholders to solicit their inputs and comments. And the final map and report are prepared and will be delivered to stakeholders. And the final data is also uploaded to the Philippine GEO portal. So what is the primary data that's used to generate a coastal resource map? This is a sample of a Sentinel-2 image. Sentinel-2 image is a level 2A or the atmospherically corrected surface reflectance is a wide swath, high-resolution, multispectral imaging mission supporting Copernicus land monitoring studies, including the monitoring of vegetation, soil and water cover, as well as observation of inland waterways and coastal areas. The Sentinel-2 multispectral instrument has 13 spectral bands, 4 bands at 10 meters, 6 bands at 20 meters, and 60 meters spatial resolution. So these are the 13 bands that is included in a Sentinel-2 image. So let's take a look at the individual bands from a Sentinel-2 image. Band 1 is used for monitoring coastal and aerosol studies. Band 2 is for bathymetric mapping and distinguishing soil from vegetation. It shows underwater features like corals and seagrasses. And band 3 or the green band is used for assessing vegetation and emphasizes peak vegetation. The red band are specifically designed to discriminate vegetation slopes. And the near-infrared bands penetrates haze, emphasizes vegetation, boundary, and the boundary between land and water and other landforms. So how can we use the Sentinel-2 image to come up with the preliminary coastal resource map? It must undergo a layer stacking. Layer stacking is a process of combining multiple separate bands in order to produce a new multi-band image. These type of multi-band images are capable of displaying colored images which are useful in visualizing and identifying the available land use or land cover classes and other coastal resources. These are sample of layer stack Sentinel-2 images. These are bands 431 and band 432. These are combinations used to detect underwater features like corals and seagrasses. And the bands 8, 11, 2 were used to identify mangrove features. So after layer stacking, to produce a coastal resource map, we use the object-based image analysis. This is a method in remote sensing and image processing that involves the segmentation and classification of images based on the characteristics of objects within the image, rather than analyzing individual pixels. The purpose of enhancing satellite image is to extract more useful information, reduce noise and artifacts, and make the data more suitable for analysis and visualization. Enhancements can highlight specific features in the imagery, making them more prominent and aiding in their identification. For example, enhancing mangrove areas can assist the understanding of land use patterns and specific land covers. In UBIA, the image is segmented into meaningful objects or regions based on similarities in spectral, spatial, and other similar properties. Segmentation involves grouping neighboring pixels with similar attributes into larger entities. And once the image is segmented, classification is performed on the objects rather than individual pixels. This involves assigning a specific class label to each segmented object, such as coral, seagrass, and mangroves. Stratified random sampling points are generated for ground validation survey. Okay. So after the production of the preliminary coastal resource map, we go to field survey. So one of the activities in field survey is the assessment of corals. In the assessment of corals, we use the FLIT method, or the photo line intercept transect method. This is a method of assessing the physical characteristics of corals by taking digital photos along a transect line for analysis and evaluation. A 50-meter transect line is established using a measuring tape. The measuring tape shall be draped directly on the seabed in a straight line. Pictures will be taken at every meter along the transect line using underwater digital camera while maintaining a constant vertical distance, approximately 1 meter between the camera and the transect line. So in this part of my lecture, let me show you a simple video taken during the field validation. Ah. Let me try it again for a while. Okay, let's try it again. Okay. Oh, okay, so uh, let me try to fix this for a while. So okay. So sana nagtuloy-tuloy. Ayan siya. And so this video was taken during the field validation survey in the province of Catanduanes last April 2023. This video was arranged by Ms. Alakate Nuez during the coral assessment done in the province of Catanduanes. The selection of coral assessment sites follows three criteria. Uh, First, the coral assessment site must be inside or near the boundary of a marine protected area or MPA. In cases where there are no MPAs, areas with extensive coverage of corals and seagrass are selected based on the preliminary coastal resource data. Extent of the site should satisfy the required dimension of the assessment sites of corals and seagrasses. A team is composed of at least two licensed open water diver and at least one marine biologist. The coral assessment is done through scuba diving. Scuba, or the self-contained underwater breathing apparatus, allows the field survey team to explore the underwater in a safe and controlled manner. Almost all of PCRD personnel are licensed scuba divers and has been trained in open water scuba diver course. PCRD personnel shall undergo this training, which is part of the RDAB Technical Learning Curriculum Program, in the application of photo line intercept transect method for coral assessment to ensure safety, learn practices on responsible diving, and necessary skills and knowledge to conduct coral assessments on coral reefs without causing harm, and reduces the risk of accidents and increases the safety of both the divers and the marine environment. So while the video is still on the play, let me also take this opportunity to thank the local government units in Catanduanes, the Coast Guard Station in Catanduanes, and Penrom Imelda Baltasar of Penro Catanduanes for the assistance to the team in the conduct of ground validation and assessment of corals and seagrasses. And we also thank the DNR Region 5 Conservation and Development Division, the Coastal Resources and Foreshore Management Section for the scuba tanks that was used in the coral assessments. Okay. So this is the site in Barangay Toytoy, a part of Palumbanas Islands in Caramoran, Catanduanes. Ayan po. Ayan. Thank you for watching. For the seagrass assessment, quadrant method is applied for this assessment of seagrass. Three parallel lines is established perpendicular to the coastline. Each transect line is 50 meters in length and laid 25 meters apart. Both ends of each transect line is secured with a peg. The start and end positions of each transect line is determined using and recorded using a handheld GPS. A 0.5 meter by 0.5 meter quadrat shall be laid starting at 0 meter and at every 5 meters thereafter until the end of the transect line. Assessment is performed in each quadrat and all observations are recorded using a slate board temporarily. Pictures of the quadrat frame shall be taken from an angle as vertical as possible. The recorded data in a slate board are the seagrass species, the percent cover of seagrass or algae, the seagrass heights, and the sediments present. So these are the photos of PCRD personnel conducting seagrass assessment. Okay. So some seagrass assessments are done in shallow waters and some are done in deeper part of coastal areas. Okay. And these are the PCRD personnel conducting field survey validation of corals, seagrass, and mangroves using their handheld GPS. Ayan. So as the output of the project, this is a sample output of a provincial coastal resource map in the province of Dinagat Islands. It shows the spatial location of corals, seagrass, and mangroves. It also indicates the data on area derived from the shapefile. And the produced coastal resource map are also delivered to stakeholders and will be uploaded to the Philippine Geoportal. Through the Geoportal, this data is open for free and free download at no cost. So what are the ways forward on the coastal resource mapping and assessment? First is the research on the application of AI for land cover and coastal resource mapping. This research aims to develop an AI model that can automate the prediction and mapping of selected land and coastal resource features from Sentinel-2 images. There are three advantages in using AI. First, it enables the automation of crucial but time-consuming and repetitive processes, freeing up human resources for higher value work. Second, AI unlocks insights that would otherwise be hidden in vast amounts of unstructured data that previously needed to be managed and analyzed by humans. And third, AI can combine the performance of tens of thousands of computers with additional resources to tackle the most challenging issues. Therefore, it is important to use AI. So this is the sample of output of the model that can detect water and land. In this slide, you can see that the model can process a whole scene of Sentinel-2 image and predicted water and land. This can be used to delineate shoreline and other inland water bodies. Another model that was made through the research was the model for mangrove detection. So the deep learning model for mangrove was able to classify correctly the mangrove areas in most of the scene. In areas where mangroves were situated along riverbanks and fish ponds and can be seen as long thin strips in satellite images, the result shows not all were delineated and it it will be a room for improvement. Other types of vegetation were also classified as mangroves. Another model was made for the detection of seagrass and corals. It can be noted that the model was able to classify underwater features. However, there are misclassification and there are misclassified predictions for both classes. The pink outline areas are the corals, while the green outlines are the seagrasses. By combining traditional remote sensing techniques with AI, the results can be improved for accuracy, faster data processing, and lessens the potential for errors. And another part of the strategic plan for the Costa Resource Map is the use of uh, unmanned underwater vehicle or UUV. So the automated rapid reef assessment was developed by the team of Dr. Maricor Soriano of the University of the Philippines with the aim of developing a cheaper alternative technology for reef assessment. The system has the capability to generate permanent visual records of the current state of the reefs and identify potential marine sanctuaries. This provides a fast and diverless method of coastal survey and mapping services for creating permanent visual records of the marine environment. Okay. So that ends my presentation. Thank you very much. Mabuhay tayong lahat. Back to you, Joyce.
Yes po, sir. Thank you, Sir CJ, for your very thorough and visually appealing presentation of the coastal resource mapping and its impact on our on climate change. So, ayan, nakita nyo naman talagang sumisid pa sila, sir, at ang kanyang team sa ating mga karagatan para makuha yung photos and footages na present niya sa atin kanina. So we hope that somehow the information and knowledge shared today will be retained po in our minds. More importantly, we also hope that every one of us here will also share and pass on this information to others. And we hope that everyone will actively participate, even in our small and personal ways, to help fight climate change. So now, let us move on po to the open forum or question and answer portion of our webinar. Anybody here po, especially po dun sa ating YouTube live, who has a question? Wala pa po kasi akong nakikitang question. Baka meron po kayong mga tanong dyan. Ayan, meron pong mga nag-chat dito from Municipal Disaster Risk Reduction Management Office ng General Tino, Nueva Ecija. Hello po. Municipality of Sulop, Davao del Sur. Meron din po from local government unit ng San Jose. Yan. We also have students from, eto marami-rami to, PUP Santa Mesa. Polytechnic University of the Philippines. Yan. And meron din pong from Southern Luzon State University, Tagkawayan Campus. Yan. Ayan, may question. Can we request a copy of the presentations? Yes po. Isend na lang po namin yung presentations ng ating mga resource person sa email po na ginamit nyo during the registration. Tama po ba, sir? Ma'am?
Yes po. Oh, actually, ang tawag dito, I already took the initiative of asking our resource persons kung sakaling may manghingi ng PowerPoint presentations nila, kung pwede natin ibigay. And they answered naman in the affirmative. Ibibigay daw nila yung copy ng slides nila. Pero ititweak lang nila para, alam mo na, syempre igagawin nila yung PDF, gagawin nilang PDF file, yung kanilang PowerPoint.
Okay po.
So, padala ko na lang siguro after ko mag-gather yung email nila from the attendance and evaluation form. Thank you.
Okay po. Thank you po, sir. Ayan. Wala na po ba tayong questions? Naku, mukhang kumpletong-kumpleto na yung nai-present ni Ma'am Steph at ni Sir CJ, ah. Wala nang questions? Ayan po, may nag-greet from MDRRMO ng Santa Rosa, Nueva Ecija. Hello po sa inyo. Ayan po, may question po si Sir Charles Darwin Cruz. Yan, good morning po. As said earlier, there is a limitation of Sentinel-2 regarding with the cloud. Is there a way now on how we can eliminate the clouds so we can have more clear visualization? Hello po. Ayan po, si Ma'am Steph.
Okay. Hi, Joyce.
Yes po.
Okay, so talagang actually very problematic talaga yung ano no, yung cloud persistent cloud cover kasi alam mo naman tropical country tayo. So in the case of land cover, what we do is since like I've mentioned, the temporal resolution of Sentinel-2 is every 5 days pwede tayo maka-download na bagong image. So what we do is that pag medyo madaming cloud cover. So, kumukuha kami ng another set of image. So, and then what we do is we mask the clouds using yung mga several images that we collect. Okay, so yun. Basically, yun yung ginagawa namin dito sa office. So, for example, if you're going to mosaic one province, syempre, like if a province covers more than one image, so medyo it's composed of, medyo marami kaming dina-download para lang makakreate kami ng cloud-free satellite data. Yun.
Ayan po. I hope po na-answer po yung ating question. Thank you po, ma'am. Ang wala na talagang tanong, ha?
Sige nga, Joyce, ako nga magtatanong.
Ay, sige po. Go ahead, sir.
Oo. O yung coastal resource mapping. Sige. Ay, naputol yata ako. Anyways, yung question ko is, for CJ and Steph, what is more challenging, yung coastal resource mapping or yung land cover mapping?
Anybody po from our resource persons who want to answer po that question? Sir CJ, Ma'am Steph. Go
Sa
ahead.
akin, Joy,
Go ahead. Okay.
hi Jeff, para sa akin, pareho namang merong challenges yung paglaland cover at saka pagko-coastal resource mapping, ano. Kasi, syempre, ang tawag dito, ang daming, like sa land cover, ang dami mong binavalidate na area. So, syempre, meron ding mga, syempre, yung mga weather conditions, affected din kami. Tapos, kunyari sa peace and order situation, ganyan. So, and of course, yung land cover, like isang probinsya, gaano kalaki yon, 'di ba? So sa tingin ko si RMA ganun din kasi na-experience ko din, 'di ba? So syempre ang hirap din na ang hirap din magmapa ng corals and seagrass, tinitingnan mo tubig lang siya, 'di ba? Ganun. So, yun para sa akin pareho siyang challenging. Para sa akin equal lang siya. Yun. Ewan ko lang kung ano sa palagay ni CJ. Thank you.
Yes, sir.
Madagdag ko lang sa coastal resource mapping kasi we are mapping underwater features. So when you look at the preliminary data, which is the Sentinel-2 image, merong barrier between the sensor and the corals and seagrass. Meron siyang water na minsan sa satellite images, turbid. So, depende sa water condition yon. So, minsan hindi mo siya makikita sa ibang scenes. So, yung isang challenge din is maghanap ka talaga ng suitable na Sentinel-2 image. And then of course dun sa pag-conduct ng validation. So, yun nga sabi ni Ma'am Steph, yung safety, peace and order sa area. So, I can agree na it's more of or less equal naman po yung challenges na na-experience ng coastal resource mapping sa land cover mapping.
Thank you po, Sir CJ. Ayan po. Meron pa pong isang question. Sabi dito ni Sir Arnold Santos. Curious question lang po. Bakit 3.3 millimeters yung global average ng sea level rise? Then locally dito sa atin ay 14.4 millimeters. So I think si Sir Jeff po ang sasagot. Sir Jeff?
Yes, Joyce, thank you. Thank you, Arnold, for the question. Although that specific information was mentioned by Sir CJ during his presentation, but I believe magkaibang references yung ginamit niya on this information. And I believe mas may credibility sumagot nitong question na ito yung ating hydrography branch, particularly si Sir Dennis Bringas ng Physical Oceanography Division ng HB, considering na na-quote ni Sir CJ na yung 14.4 millimeter na sea level rise increase dito sa Philippines ay galing doon sa kanyang presentation during his interviews sa mga media networks noong nakaraan lang. So para maging thorough yung sagot natin dito, we will be referring this question to Sir Dennis, and then kung ano yung magiging sagot niya, we will be emailing it to you para masatisfy yung curiosity mo. Okay? Thank you.
Thank you po, Sir Jeff. So, yun po, i-email na lang po namin yung sagot sa inyo, sir. Ayan. From Santa Rosa, MDRRMO, paano po kami magkakaroon ng access sa mapping ng vegetation for much better assessment and identification para sa proper alignment ng PPAs for the community, for resilience, at improved economy? Steph?
Hello po, thank you po sa question. Okay, so in terms of access po para dun sa land cover, as I've mentioned, yung Philippine Geoportal po provides open access data para sa land cover natin. So if you want to download yung land cover po natin para magamit po ninyo as reference para sa vegetation mapping, pwede po ninyong i-access sa Philippine Geoportal. Yun po.
Ay, sorry po. Parang nawala po yung audio ko or ako lang po ba yun? Natapos po ba yung sagot ni ma'am? Sorry.
Yes po, Joyce. I hope nasagot ko po yung tanong yung question po ninyo. Thank you po.
Yes po, ang official ang address po, website po ng ating pong Geoportal Philippines ay www.geoportal.gov.ph po. Yun po. Yun po yung official website po natin. www.geoportal.gov.ph. So you can access po all the ENR data po na nandun po sa portal na yon. Free of charge po.
Ayan. Meron pa po bang questions? Wala na po bang hahabol na questions? Sir Jeff? I think parang wala na, sir.
Yes, mukhang parang wala na nga, ano. So most
Opo.
likely, I believe naman na na-satisfy natin yung cravings nila for learning when it comes to land cover mapping and coastal resource mapping. So kung wala na po tayong questions, Joyce, I guess we can continue with the program. Thank you.
Yes po, sir. Okay po, sir. So if there are no questions na po from our participants, let us move on to the last part of our activity. So to formally close our webinar, may we call the Assistant Director of the Resource Data Analysis Branch, dear Violeta A. Quiliza, for her message. Dear, good morning.
Yes, good morning, Joyce. Thank you so much for that for our seminar today. It is truly a success. So, good morning, everyone. Thank you so much for your attendance and valuable participation in this webinar in observance of our Climate Change Consciousness Week for this year. And to our lecturers on the ENR Mapping Initiative, thank you for their brilliant lectures. These are our very own Bonifacia B and Seiji Soliven, who are dedicated, and their presentation is such an inspiring to us all. So also to our facilitator, headed by Mr. Jeffrey Kodala, and you, Ms. Joyce Yuko, and my gratitude to the management for having this webinar possible. Thank you so much sa inyo lahat. So it is truly annoying to everyone that when it comes to degradation issues of our environment, especially the impact on climate change in our coastal and marine resources. And if I recall a while ago, that there are about 50 to 70% losses of our mangrove from 1960 to 1980 due to the forest degradation that threaten our economy and coastal ecosystem. So along with the sea level rise scenarios in Metro Manila, it is 4 times faster than the global average, including at least 20 tropical cyclone that passes through our Philippine area of responsibility each year. So also our corals and seagrasses, which are the natural breeding stations of our marine life and resources, will be exposed to 90% degradation by 2030. So our forests were leading too much extinction of the biodiversity. And if we could not mitigate the global warming and other human-related activities, this will lead to total degradation of these resources. Then, what will be our future by the next 20 to 50 years? In this way, the National Mapping and Resource Information Authority, through the Resource Data Analysis Branch, took an initiative in the mapping of the environment and natural resources in support to climate change mitigation. So the land cover and the coastal resource mapping, that is a project of the RDAB, is complemented with the use of the scientifically known procedures using the remote sensing and GIS application, which could identify and map the extent of hazards in a given areas, as well as the significance of vulnerability assessment specifically on the land cover. So with this, we could eventually figure out the areas prone to flooding, to landslide, and to other climate change related hazard. So the mapping of this hazard in agreement and in coordination and collaboration with the national government agencies, the local government units, and other organizational institutions can implement these measures and enhance resilience, such as the building of our infrastructures, improving the drainage, and protecting the natural habitat. So in the same manner, we can engage and empower our counterparts on the community to our land cover mapping activities to participate in the climate change adaptation efforts. Although the process sometimes includes some difficulties and limitations, but still, we are committed to continue this activity towards protecting our environment. So preserving our planet is a shared responsibility. It is essential to work together hand in hand to achieve a sustainable environment. Again, thank you so much po for this opportunity for sharing us your valuable time and wishing you all good luck. God bless and stay safe everyone. Thank you. Yun lang po.
Yes po, thank you po, Adir, for your message.
Salamat,
And
Joyce.
yes po, thank you po, Adir. And yes, I think we can all agree naman po that this webinar has been really helpful and informative for all of us, especially on the topic of mapping, climate change, and the environment. So, ito last na po talaga to give lang some administrative notes. May we call on our webinar's activity lead, Sir Jeffrey A. Codala. Sir Jeff?
Yes, thank you, Joyce. First and foremost, although nag-close to si Ma'am Violi, I would like to take this opportunity to thank the Resource Data Analysis Branch for the overwhelming support po na ibinigay niyo po sa amin sa IEC Management Team for the conduct of this year's 2023 National Climate Change Consciousness Week webinar. So, right from the very beginning, hindi po nahirapan ng inyong lingkod makipag-coordinate sa inyo pong branch. Kaya with that, maraming salamat po. So, to give you some administrative notes po with regards po on this just concluded activity natin. Ano po? So, alam ko po, napaka-importante po sa inyo ng inyong certificate of attendance. But in order for you to secure a copy of the certificate of attendance, kailangan po muna nating ma-accomplish at ma-submit po yung tinatawag po nating attendance/evaluation form, which I believe po ay ang link ay already posted at nakapin na po dyan po sa live chat po natin. So once po natin na-receive po ito, bigyan nyo po kami ng 10 working days to process yung pong mga feedbacks and responses po na ibinigay nyo sa amin. And from that, and after that po, we will be sending you your copy ng inyong certificate through your registered email. Kaya mag-ingat po tayo ha sa mga emails po na tinatype natin. Dahil sometimes po, kahit po nakapag-attend tayo, nakapag-accomplish po tayo ng evaluation form, pero kung hindi naman po natin maipadala po yung certificate dahil mali po yung email address po na na-register natin, particularly po in that particular form, hindi rin po natin ito maipapadala. Kaya be extra mindful po sa email address po na inyong ilalagay dyan sa attendance evaluation form. So, 10 working days po after na-conduct po ng webinar, asahan po ninyo na we will be providing you a copy of your certificate. And again, we will be also be providing you yung, so nagbigay na ng thumbs up yung ating resource persons. We will be providing their respective PowerPoint presentations in PDF format for your reference po. So on behalf of the NAMRIA Administrator, Undersecretary Peter N. Iangco, and the rest of the NAMRIA officials and employees, thank you po and maraming salamat po sa palagiang support ng inyong ibinibigay sa National Mapping and Resource Information Authority sa kanyang mga IEC activities. Marami pong salamat. Thank you, Joyce.
Thank you po, Sir Jeff. And again, to all our participants, we thank you po for attending our webinar on ENR Mapping Initiatives in support to climate change adaptation in line with the celebration of the 2023 National Climate Change Consciousness Week. Again, this has been your host, Joyce Ferrer. And ayun po, maraming salamat po sa lahat at magandang umaga po.